we take type 5 problems. If integral dx by a cos squared x plus b sin squared x plus c, that means the denominator cos squared x plus sin squared x and constant. Squares are there, then divide numerator and denominator by cos squared x and put t is equal to tan x. This is the hint that is given. Now we take a problem number 1, integral dx by 1 plus 8 cos squared x. So divide numerator and denominator by cos squared x. Now what will happen to the numerator? Dx by cos squared x is what? Secant squared x. Secant squared x into dx. And when you divide denominator by cos squared x, 1 by cos squared x is what? Secant squared x plus 8 cos squared x by cos squared x is what? Only 8. Now this secant squared x is written as 1 plus tan squared x. So 1 and 8 gives you 9. Integral secant squared x into dx by 9 plus tan squared x. Now put t is equal to tan x. And what is dt? Differentiation of tan x with respect to x, which is what? Secant squared x into dx. So the numerator becomes only secant squared x dx becomes only dt, and denominator is what? 9. 9 is written as 3 squared plus tan squared x is written as t squared. It is what? Denominator a squared plus x squared type 1 by a tan inverse x by a. So 1 by 3 tan inverse t by 3. T divided by 3 plus c, and that is nothing but 1 by 3 tan value, t value substitute. Tan inverse t is what? Tan x by 2 by 3 and bracket close plus c. Now we take the second problem. Integral dx by 1 plus 3 sin squared x. Cos squared x is not there. Even then you can divide numerator and denominator by cos squared x. Then what will happen to the problem? Integral dx by cos squared x is what? Secant squared x into dx divided by 1 by cos squared x is what? Secant squared x plus 3 sin squared x by cos squared x is what? Tan squared x. Now here numerator you keep like that only, secant squared x dx. Denominator is secant squared x is what? 1 plus tan squared x. Tan squared x and 3 tan squared x is 4 tan squared x. So totally it becomes 1 plus 4 tan squared x. Now you see denominator is what? A function of this one tan squared x. So t is equal to tan x. And dt is equal to secant squared x into dx. So what will happen? Integral numerator is what? Completely dt by 1 plus 4t squared, because tan squared x is there. So whenever quotient of t squared is there, you take out, and that is what? 1 by 4 integral dt by, here 1 by 4 will be there. 1 by 4 is written as 1 by 2 plus t squared. Once again it comes to the first type of problem. That is what? 1 by 4 into 1 by a, 1 by 2 into tan inverse t by half plus c. And here this 2 cancels with this 4, leaving behind 2. So totally you get 1 by 2 tan inverse t value is what? Tan x by 2. And this 2 goes up to the numerator. 2 tan x by 2 and then plus c. Next we do any standard problem, that is what? Third, integral dx by, here cos square x and sin square x, both of them are there. So a squared cos squared x plus b squared sin squared x is there. So now divide numerator and denominator by, divide numerator and denominator by cos squared x, always, whenever this type of problem is there. You get numerator, dx by cos squared x is what? Secant squared x dx as usual. Here a squared cos square x by cos square x is only a squared plus b squared. Sin square by cos squared is what? Tan squared. Already the problem is in the standard form. Put t is equal to tan x. dt is equal to secant squared x into dx. So numerator becomes integral dt by a squared plus b squared tan squared x. T square only, not tan squared x, it is only t squared. Here a squared plus b squared t squared, b squared you take as a factor, 1 by b squared integral dt by a by b whole squared plus t squared. Now this is 1 by a tan inverse, 1 by b squared is there, a is what? A by b, 1 by a by b into tan inverse t divided by a by b plus c. Here 1b cancels, and that is what? 1 by ab tan inverse b by a, because 1 by a by b becomes b by a, t is what? Tan x bracket close plus c. Similarly, a problem where instead of a squared you can have 9 and b squared is what? Say 4, or this is 25 and this is 16, like that you can work out.